Okay, this is the video tutorial for the homework 4 of Lab 52. The difference between this homework and the one that is assigned to Lab 51 is which problem you have to submit. In your case, you have to submit problem number 2. Now, for the other lab, Lab 51, they have to submit problem number 1. Now, I did a video for doing problem number 1 and I called it the solution to lab 51. I'm not going to repeat it here. If you want to see how number 1 is done, please go and check the video for lab 51. For you, I'm going to be solving only this problem, okay? And of course, the people in the other labs, they want to see how this problem is done, they have to come to your video part. So basically we have, this is an assembly, it has to be done as an assembly. There is two rings which are fully bonded somehow. The outside one is made out of steel, the inside one out of aluminum. The dimensions are given here, and they're fully bonded at the interface. Okay, that's a different matter. How do you make it fully bonded, etc. This entire structure is subjected, this entire assembly is subjected to temperature rise of 50 degrees Fahrenheit from room temperature. And what we like to know is what is the stress distribution, what is the deformation of this. And you're asked to use a 30-degree sector because of the symmetry. Obviously, you can make a cut through halfway through the disc. The top and the bottom will be the same. And you're asked to take a 30-degree sector, just like the one that we did for the rotating disc. Remember, we took a sector of that. And you're asked also to do a local mesh refinement around the interface. Okay, obviously the most important, the most appropriate element for this problem is intended to be the solid elements. Okay, all right, good. So let's go ahead and do this. Let's start with the product file because this is an assembly. Immediately I'm going to save it. File, save management, save as. On my desktop, I'll create a new folder. I'll call it homework 4, lab 52, and this is problem 2. Okay, so we put it there. And for the product name, your student ID number 1, 2, 3, 4, 5, 6, 7, 8, 9. Your last name, Euler. And this is homework number 4, lab 52. And problem 2. I want to remind you that when you're doing an assembly and you submit your work, if it's a finite element, you have to submit the product file, any parts that you use to make that assembly. So here there's going to be 2 parts, and your analysis file. Okay, you say okay, and we say okay. Let's insert our first part, insert new part in there. And I'm going to call this thing so that I can distinguish it. I'll call it outer one, which is a steel, by the way. Outer one is a steel. So properties, outer ring. How about that? Ring, which is steel. Yep. Outer ring. And this is the part name. Outer ring dash steel. You make it. So I'm going to double click on outer ring. It's going to take me to part design on a convenient plane. On that vertical plane, I will sketch a rectangle like this. Now, because I'm using half the height, notice that this height is 2 inches. We're taking half of the height due to symmetry. I can make a 1 inch high, this thing 1 inch high. Okay, and let's give some dimensions here. The distance from here to there, I believe that is 3, and the distance from here to here, oops, the distance from this to that edge, that is 5. 5. Okay, so this is the steel ring. Exit, shafted, right there, shafted, about the Z axis by 30 degrees. We take a 30-degree sector. Oops. Okay, this is 0, the other one is 30 degrees. That's what I meant, 30. Okay. Preview, there we are. Okay, while you're at it, we make this thing out of steel. So metal, steel on this part. Okay, outer ring part. You can do it here, or you can do it here. It really doesn't matter. We can close it. There we are. Okay, now if you want to save this, because this is a part, remember you haven't saved it, you can of course go to File Save Management, and you notice that it says this is new, you haven't saved it. The other option is you go to top level, very top, assembly level, see that, this is assembly, and just click on the floppy. Automatically will save that part for you. In fact, if you read that message that you saw, it says I'm going to save the part. Now, insert the next part. Insert, new part. No. Right click properties. Let's change the name here. So this is the inner ring dash aluminum, right? Aluminum. Or aluminium. I don't know. Not ali. Aluminium. Okay. Oops. Aluminium. And same thing down here. Inner ring dash aluminium. Aluminium. I don't know. Okay, let's make it. On a convenient plane of that same vertical plane that you drew this guy, you draw a rectangle again. Let's zoom in. Rectangle again, like that. Okay, give it dimensions. First of all, I can give it dimension, but I can also say this guy control that guy coincident, so that they're the same height. And this edge control that edge coincident. Good. And the distance from here to there is 1 inch. It's up to you how you want to do this. So this is how I did it. Okay, exit, shafted, 30 degrees. This is the sketch. Oh, no, about, clear, about the Z axis. That's what I wanted. Okay. Cancel. Let's do it again. Shaft this about Z axis by, I think it should be 30. Preview. The reverse direction. Okay, that's much better. Something I must have screwed up in this sketch. So let's go ahead and check that sketch. So this shaft, this is the sketch. What did I do? Oh yeah, the sketch when I made this thing, or should I made a coincidence with that guy? Because accidentally I coincided with this fellow. Let me see if we can fix this thing. that control this. Can I make it coincident now? Oh, that's better. And this, let me delete that. Okay, so I'm gonna clean this up. There we are. Okay, exit. There. Okay. So let's make this thing out of aluminum, metal, aluminum on this part. We say okay. All right. If you want, you can change the color of these two. These also, it's up to you, but I'll change the color here, graphics, so that that looks different. Actually, not here. Let me see. Properties, can I do it from there? Graphics, yeah. So how about making it yellow, something like that? Okay, very good. So you want to save everything? Go to top level assembly, click on the floppy, and wait. There we are. Okay. So now we're done here. Okay. So we're going to go to generative structure analysis. CATIA sees two parts. Immediately it meshes it. Now let's check the mesh here. The size is okay. So these are all linear. I used all linear. Parabolic is more accurate, but you know, you just have to be careful so you don't put a small number, very small number. Now, what do you want? You were asked, let's look at the mesh first. Right click, mesh visualization. There you are. Change the rendering. Okay, so you can see that there is the seam here. This side is aluminum, this side steel, but you're asked to make sure that there's a fine mesh on around that, around that seam. So here's what we have to do. We go deactivate this. We know how to do local mesh refinement. You go there, we did this thing in the first couple of days of the course. Here, right there, it says, okay, you want to fine mesh? Which one of these two you want to make finer? Well, let's say this one is there for the outer ring. Okay, it says where. So let me hide that and select this face. You see that? And the size of it right now is this. So let's make this thing, I don't know, maybe 0.05. Let's see how it looks like. Ooh, wait, good. Let's do the other one now. So another local mesh refinement for this fellow. It says, where do you want it? Well, remember, I want it on the face right there, on this guy, right there. And 0.05 is 5. Fine, fine, fine. Okay, so let's look at the mesh now. Right click, mesh visualization. And you can see that what happens is that at the seam, there's a finer mesh. Okay, very good. So let's save it. File, save management, analysis, save as lab 52. Let's see now. Desktop, lab 52, meaningful name, same as your part. Oops. 1, 2, 3, 4, 5, 6, 7, 8, 9. Your last name is Euler. Okay, and then the stuff that you have up there. Euler. What do we have up there? Homework 4 underscore lab 52. What else do we have? Problem 2. And analysis. Okay. Yep. Save. Okay. Deactivate the mesh and do the rest of the problem. Okay, so we have a surface slider at the bottom, surface slider at the both pieces, because remember we made the cuts. I didn't make a cut, I made half of the model. Okay, and there's surface slider on this side and that side, and I combine them all in the same surface slider box basically. Okay, the top is free though. The top is free. Now save everything. Okay, what is the load? The load is temperature rise. You go here, there is the temperature rise, you click on it. It says the support. It doesn't matter what you pick, you have to select both of them. Both of them are, these are subject temperature rise, this guy and that guy. Notice it puts a big T here, and you're told 50 degrees above the reference temperature, which is 72 degrees. Okay, so this is a temperature. Oh, this is temperature. The temperature rise is going to be the room temperature. Let's say 72 degrees plus 50, 122 degrees. 122 degrees. You see, temperature rise. This temperature that you put here is the temperature of the object. It's not the temperature rise. So you add 50 to it, and you get the value. Now, if you wonder, let me show you something. Let me cancel that. So, if you wonder where did that 70 come from, if notice that as soon as I did this temperature thingy, I got a branch here called environment right there. Okay, so if you double click on it, it tells you what is the initial temperature. 68. This is the room temperature that I was talking about. So if you want to change this thing to 0, if you want to change this thing to 0, then you add 50, for example, to 0. But if it's temperature rise and this is your room temperature, it's going to be 50 plus this. So it's going to be 118. Okay, so all right. So let's go back here to be strictly correct. This should be 118. Okay, good, good. So this is it. Save everything, run it. Don't worry about it. Remember this warning. Rotation is not the degree of freedom for solids. Yeah, you know that. You know that. There we are. Look at the deformation. Obviously, this is going to go out. You can see that. Oh, wait a minute. Now, there's a problem here. One thing we completely forgot. That's a bad mistake. This guy has no idea that there is a steel block sitting there. And the steel has no idea there is an aluminum block sitting there. These assembly problems, you must create connections between them. Okay, just to show you what I mean by that, if I say show me the displacement, for example, okay, notice that basically this aluminum is going to go through the steel. They don't respect each other. So deactivate this last one. That's a bad mistake. Deactivate it. Okay, so let's create a connection. Analysis connection between, let me hide this, the surface of the aluminum for the second component, the surface of the steel. Let me bring this thing in the front, show you what happened here. So notice that puts this little dot here, the white dot. That's because of the connection that it created. There we go. This connection, we are told they're fully bonded. Fully bonded. That means they're fastened. Okay. Let's make it fasten. Look at the face-to-face analysis, face-to-face connection properties. The first one says slider. The second one says contact. Next one says fasten. Fasten. Select that connection that you created. This or from the tree. This little dot from the tree. Either way. So notice that it looks like it puts a fastener there. Okay. To remind you that this is a fasten connection, and then run it. Don't worry about that. Don't worry about that. Say yes. And now look at the deflection. To you, it may be like the other one that you've got, but the other one is just simply wrong because it does go, that does penetrate the steel, okay? They don't know that, they're there. So if you look at the deflection right there, they go together. If you think about it, material shading, average ISO, material shading, See how they go continue? They're the same color. See that? How they're the same color? Okay. I'll go back and redo it where connection was not created. Just show you this, that there's definitely something wrong. Look at the one meso stress. One meso stress, of course, is discontinuous because the properties are discontinuous. When there is a discontinuity in the properties, Young's modulus and things like that, the stress is going to be there's going to be a sudden jump. Now, to convince you that without this thing that we did, it's wrong. So let me save this thing first of all. I am going to remove that fasten connection property. I'm going to remove this and run it and show you the displacement. As I said, it will run, but look at the color. See, these are moving together. They cannot be different colors because this guy doesn't respect the other one and the other way around. But when I made a connection and made the connection fasten, they moved together. This color was the same. Okay? So looks okay. It ran, but it's big time wrong. Okay? All right, folks. So let's stop this. If you want to see how problem 1 is done, please go to check the video for lab section 51.